question on the screen, guys? It's a similarity question. Remember, 2 ways to prove similarity. The sides are equal and the angles are equal and the sides are in proportion. So over here, we're looking at sides in proportion and we're trying to figure out the values for QF and MN. Please drop your answers in the chat if you've got any for me. All right. Hi, Christina. Awesome to see you. I'm going to get started in about the next 2 minutes. Have a look at the question. We actually spoke about this question on Wednesday, so it shouldn't be too hard to do. Hello, Tiana. Hi, Tabsilia.
Hi, everyone. How are you guys doing today?
Teacher Nell's in the building.
Hi.
Hi, Tiana. And Patu's here. Hello. What's with that face? With that dew-eyed face I'm seeing? That emoji.
Are you okay, Patu?
That's actually what I'm asking. Are you okay? Hi, Lusanda. Hello, Tiana. What's up, my sweetie?
Ma'am, hi.
Hello.
How's ma'am?
I'm good. How are you?
I'm good, thanks, ma'am. Ma'am, so ma'am see those quadrilaterals now, ne? It's making sure. Like it's one of the things, ne? It's even worse than trig. Okay, trig isn't that bad, but this is bad. Ma'am, I'm not fine.
Okay, I'll give you a quick refresher. Okay, so remember that the sides are always going to correspond. Hey, Tiana, so I know that if I highlight MN, which side on this triangle, on the other triangle, is going to correspond with MN?
QR.
Oh, QR, the first two. And then if I highlight the last two, if I highlight NO, which one is that going to correspond with?
RS.
So we're on to something. We don't know nothing. We know something. Right. So I can go MN over QR, like you said, needs to be equal to NO over RS. Can you give me the last? Remember, the last is going to be the first and the last. So I'm going to go MO over
QS.
Beautiful. Over QS. And then all we have to do is replace the number. That's all. Is it ringing a bell?
Ma'am, this is okay. Not the other part.
The other part is not that bad. It's not that bad. Okay, let's look at this. We're going to use these two. I'm going to use MO and QS and NO and RS because the question says calculate for QS. Right. So I'm going to go and write QS. I'm going to replace QS with X. What is NO? Can you see what the value of NO is, Tiana?
NO is 12.
Good. So 12 over RS is
30.
So T is equal to MO, which is
15.
15 over QS, which is
X.
What's my next step?
Ma'am, sorry, what was the question?
What is my next step?
Cross
Multiply, yes, cross multiply and solve for X. All right, that's what I want to go do for me, Mercedes. I think he just needed a refresher. It's not that it's not so. He just needed a refreshment. See, and it's coming back to you. All right, don't stress too much. All right, take it from here. All right, hi, Abigail. What's up, my sweetie? Hello, Abigail.
Hi, ma'am.
How are you doing, my sweetie?
I'm good, thanks. And how are you?
Good. What's up?
No, everything is cool.
Okay, I'm seeing the hand up, so I assumed, or did you just want to say hi and see how I'm doing?
No, no, ma'am, it's okay. You can continue. Never mind
Are
it.
you sure?
Yeah.
Okay. It's lovely to hear your voice anyway, Abigail. Thanks for joining us today.
All right.
All right. Anybody got an answer for me, guys? Simple. Just pop your answer in the chat. Calculator word. 450 divided by 12. That's all. That's it. Thank you, Kyrika and Namani. That's 37,5. All right. 37,5. All right. So we're going to be looking at similarity. Okay. Now, there are two ways to prove similarity. Does anybody remember what are those two ways that we can prove similarity? Yes, Tiana. Yes, we can. Yes, you can do that. All right. Anybody remember the two ways? Good. David's got one of them correct. 100% A. Unfortunately, David, SSS does not count because when you say SSS, what you're actually telling me is that all three sides of each of them are equal. And that's not similarity, that's congruency. So we need to remember that it's either A or sides in only or corresponding sides in Adlian is like A and PPP. Yes. Okay, but we'll take PPP for now, but please don't write PPP in the test. They won't allow it. They won't allow PPP. You need to write corresponding sides in proportion. I do. So please tell me you've been here for a while and I just haven't noticed. It's been such a long time. Hello, Joe. Lovely to have you back. That's it at the hum. All right. So every time we see that something has to be proven, we need to take it from where we see. Now it says here, prove that triangle ABC, and this one I'm definitely going to map out, otherwise we're going to miss something. Okay. So it says this when it's written as ABC, what it's actually telling me is start at the point A, go to B, and then go to C, and then close your triangle off. So we're going to go triangle A, B, C, close triangle. They're saying that this triangle is similar to triangle ADE. So I'm going to start again at A, go to D, go to E, close triangle. Right. That's what they're actually telling me here. The other extra bit of information they told me is that BC is parallel to DE. And as soon as we hear that two things are parallel, what do we automatically think, guys? What do we know about parallel anything? What are we thinking about in that moment? When they say they are parallel lines, what should we be thinking of? Yes, Patu, we're going to do this very quickly and then we're going to move on to quadrilateral. Yes, Tiana, that's exactly it. Good. We're going to think of our fun angle. That's our corresponding co-interior and our alternate angle. We're going to be thinking about those as we go. All right. So now it says that these two triangles are the same. So I'm going to start by writing in triangle ABC and triangle ADE. I need to write them in the correct order, otherwise it's not going to. All right. I need 3 statements. Can anybody offer up a statement for us that will show that something over here is equal? Now, I can tell you now, guys, we're not going to be able to use sides and proportions because they haven't given us any of the sides. They haven't given us the length of any of the sides. So this is definitely an angle. All right, Pachi, what do you think?
Ma'am, angle D is equal to angle B1.
Beautiful. B1 and D are equal. What is my reason?
Corresponding angles when BC is parallel to DE.
Beautiful. Good. I'm writing
Yes.
equal. You did that so beautifully. Excellent.
Thank you.
Corresponding angles, and she even gave me which side. Bless you, Tara. Bless you. BC is parallel to DE. I'm so happy with that. 100%. Anyone else have anything for me? Okay, Logan has already given us our third one, and I'm going to write it there, Logan. Thank you very much. Angle A is common. Good. We can see it from here because both of these triangles have A in. This one has an A and this one has an A. Therefore, A is going to be. Okay. Tiana's like, ma'am, write it the other way around. Okay. Are you saying the other way around because you've seen the other one as well, or because you want me to write D and then B1? Or which one?
Yeah, ma'am, like E is equal to C1. That's what I mean by other way around.
Absolutely, it is. It's my F the other way around. Beautiful stuff, Tiana. I'm gonna write C1 is equal to E to my C. Okay, not it for me. All right, corresponding angle. And my reason again is that BC is parallel to B. All right, now that I've got my three reasons, I can then go, therefore, triangle ABC is similar, 1, 2, 3, to triangle ABE, and my reason is going to be, in this case, angle. All right, give me a number out of 10, from 1 to 10. How confident are we feeling about proving similarity using angle? Anybody there with me? Samuel's at a 10, Tyreek is at a 10. Love it. Tiana, what's up?
Ma'am, so
Yes.
if A is common, isn't it like
Mhm.
given something? Like,
Yeah,
why is
well,
it
in this case, we can't say given. You could actually say given because we can see it on the diagram, but it's not necessary. You won't get an extra mark. Okay.
Thank you, ma'am.
No, right. No worries, Inganati. I want to know how we can turn that 8 into a 10. Ule, same with you. Aviani, same with you. Lakuma, same with you. All right, somebody said 1. Hatu, 1. -1. Oh, my sweetie, come on. Come on, okay, we're going to do another one and you'll see how easy it is. All right, let's have a look at this one that we've got. All right, now remember, guys, we need to map our triangles out in the correct way. Now, this says, prove that the following triangles are similar. So I'm going to start by going, because that's actually what I'm doing. I'm proving things. In triangle, and I need somebody to come tell me what order do my triangles need to go in. In triangle, anybody got any idea? You can put your hand up. Yes, Patu.
In triangle ABC and triangle POR.
Good, excellent. In triangle ABC and triangle P, it's actually Q. I know my P doesn't actually show. The Q. P, U, R, excellent. And then I need 3 reasons. I need 1, and I'm going to write 2, and then I'm going to skip a couple of lines for 3 because something needs to happen here in the middle. All right. Anybody? Any suggestions? Go for it. What do we first say? What's the first thing we're going to say? Give me any of them that are going to equal each other. You can decide whether it's going to be an angle proof, or whether it's going to be sides in proportion. I can already tell you now, we don't have any sides. Okay, how to take it away? Because I can see everybody.
Ma'am,
Yeah.
angle B is equal to
Mhm.
angle Q, which is equal to
Excellent.
90 degrees, and it's given.
Excellent. And what is my reason for that?
It's given.
Yes, it's given. Oh, I'm not arguing with you. Yes, it's given. Correct.
But my girl
Correct.
has said it's given, and then you're asking me the same question.
Oh, I didn't hear you the first time, is why. Okay, excellent. Well done. All right.
Okay, ma'am.
Anybody else got something that they can
Thank you.
help me with? Yeah. Anything else? Piano, what's up?
Ma'am, so, I want to say, like, because now we know the thought is 90, okay, we did know it. But now I want to say 90 plus 54, 56 maybe, plus the angle arc, like to get its sides. Sum of angles in a triangle or something like that.
You know what? You know what? If you were sitting in my class right now, I would give you a high 5 and the lollipop because like high 5, everyone in the class will get a high 5 because that's exactly what I needed. That is 100% what I need. Okay, you did that so beautifully. Thank you so much, Tiana. Angle P plus angle Q plus angle R all need to equal how much, my sweetie?
180.
Good. And what's our reason?
Interior angles over triangle.
Beautiful. Interior angles of a triangle. Oh, I swear, I'll give you the biggest hug and kiss right now. Just, mwah. Excellent work. See, it's make sure, Tiana, I definitely need you. Okay, good. So we can use this to then calculate for angle R. I want you guys to go ahead and do that. We know that. Yes, just make sure. We know that angle P is equal to 56 degrees plus Q, which is 90 degrees, plus R that we're trying to figure out. This is equal to 180 degrees. Therefore, angle R is equal to how much? I want you guys to calculate for me and tell me how much is angle R equal? Good, Patty. That's it. Technically it should be equal to 34 degrees. All right. And now we can then say what? Now that we know that R is 34 degrees, what can we say, guys? What is my next step? What can I then say? Because remember, I'm comparing two triangles. That's it. Yes, Namani. Yes, Patu. Yes, Akwandi. Good. I can then say angle C is equal to angle R. At this point, I don't even have to give a reason anymore because I've put in the work. Okay, I've put in the work. Now, the thing we have to know, especially about similar triangles, and I'm telling you guys now, this is going to come up in matric again. It's going to come up in matric again. We automatically know that if this side is equal to 34 degrees, this side over here is going to equal to how much? What is A going to equal? If C is equal to 34 and B is equal to 90, A automatically stands to reason that's 56 degrees. So we don't even have to question it. We don't even have to do any calculations. There's no other triangle that will equal 180 degrees. All triangles are equal to, 190 degrees. They will all be 190 degrees, 180 degrees. So we don't even have to question it. We can then just say angle A is equal to angle B. We don't even have to question it. And no, Akwanda, they're not congruent because congruent means that they're the same size and the same angle. Okay, we don't even have to question it. We can just say angle A is equal to angle B for the exact reason that the interior angles of a triangle are. Okay, we don't even have to, no calculation needed. We just write it down. And then I can say, therefore, triangle ABC is similar to triangle PQR. And here I can have angle, because I've proven 3. Yo, I feel like I could have left you guys alone to do that one by yourself. Really? Yeah, I mean, all right. Give me a thumbs up, thumbs down. How are we feeling about this type of proof of similarity? How are we doing? Who says thumbs up, Samuel, David? Yes. Love it. Awesome stuff, guys. Excellent. Can we follow? What is that? What is that emoji? Okay, Aviani says, ma'am, I'm confused. You need to tell me exactly where I've confused. You caught me. Why are we still at a 5, my sweetie? So why are we still at a 7? I need you guys to give me pointed questions so that I know where I can help you so that I don't leave you behind. Okay. I don't want to leave you guys behind because what we're going to be looking at next is a proof that looks at sides in proportion. And Tiana, I told you it was going to make sure. It was going to make sure. All right. I want to see if anybody can give us, because this also says prove that these two triangles are easy. Okay. All right, Avian, we're going to work through that just now. All right. So remember, this is a proof. I want somebody to venture in the chat the two triangles and the order in which we need to look at them in. Okay, Aviani says step 2 on the interior angles. Step 2. Okay, so here's what I did, Aviani. I went P, angle P is equal to 56 degrees. So I replaced P with 56. Angle Q is 90 degrees. So I replaced Q with 90 degrees. And then we were looking for angle R. So I left R as R, and that is equal to 180. Okay. That's a good question, Tiana. We should check in on Jasmine. I haven't heard from her yet. That's okay. All right. I'm seeing David and Akahang have given us some suggestions on how we're gonna target this. I kind of agree with you guys because it's kind of obvious when we're looking at our triangles. Okay, we need to make sure that they correspond. So I can go in triangle A, B, C, and triangle P, Q, R. And then I need three things. Okay, what kind of proof are we looking at, guys? Is this an angle proof? No. Good, David. This is not going to be an angle proof. We don't have what we need for that. And Tiana, you are on the money. It's a sides in proportion. Now, remember what we do every time we're looking for a sides in proportion proof. We start with the first two letters. We know that AB must be in proportion with PQ, according to the way you guys have given me the triangle. So I'm going to go AB is in proportion with PQ. I'm going to ask you guys, tell me in the chat, BC should be in proportion with what? What is BC to be in proportion with? BC is in proportion with? Let me know. That's it, Chimwemwe. Excellent, good, with QR. BC should be in proportion with QR, and that is equal to the very last, the first and last, AC is in proportion with which one? AC is in proportion with, that's it. Oh, David, 100% Chimwemwe Ogute Mwa. PR all the way to the end. AC with E. Now, if we can just prove that these sides are in fact in proportion, then we've done the job. There isn't really much else. So I'm going to go ahead and I'm going to replace things. So I'm going to go AB with the 7 over PQ, which is 2,8, is equal to BC 9,5 over QR 3,8 is equal to AC, which is 8,2 over PR. All right. Punch all of them into your calculator, one after the other, and tell me what you get. 7 over 2,8. How much do we get, guys? Punch it into your calculator and give me an answer. Okay. I'm getting 2.5. I don't know how you got 1 over 4. 2.5 should not be 1 over 4. It should be 5 over 2. So, all right. So I can agree. It doesn't matter in this case. You can give me 5 over 2, or you can give me 2 over 5, Tiana. The point isn't that. The point is that we need to make sure that each one of them matches. Okay. Now we need to put into your calculator 9.5 divided by 3.8. Give me an answer. Inganati's like, they're all 2,5, man. You're wasting our time. Yes, I agree. 2,5, which is equal to 2,5. Then, because we can see that all the sides are equal to each other, or the proportions are equal, we can therefore say, triangle ABC is similar to triangle PQR. And my reason beside is not going to be angle. It needs to be corresponding sides in proportion. Okay. Corresponding sides in. All right. I need again from you guys a thumbs up or a thumbs down. How are we feeling about proofs of similarity. Christina's already given me that thumbs up. I love it. Thank you, Nabile and Inganati as well. Love it, love it, love it. Yes, look, and Naman is still at an 8. You know, these do, I will admit, these do kind of take practice, but you'll always notice that in every proof, thank you, in every proof that we're doing, guys, we're always proving 3 things, like this one. There are 3 things. 1, 2, 3. Also up top here, in our angle proof, we are proving 3 things. 1, 2, 3. There must always be 3 things that are being proven. It's always like 9.99%. Where's my 0.01? Where is my 0.01? Hope, if you say to me, I don't know, you need to be very explicit about what it is you don't know. Okay, I need you to DM teacher Nelly and tell her, this is where ma'am lost me. Yes, I can scroll down. Here we go. Is that helping, Chimome? Chimome is taking a screenshot. Right. Are we ready for quadrilaterals? Patu, this is your moment. This is your moment. We are officially doing quadrilaterals. Okay. So we're going to be looking at the properties of quadrilaterals. And see others like, no, you don't have to, because we put in the work. We have. Okay. So you don't have to be. But when it comes to quadrilateral, quadrilaterals need to be studied to be known. Okay, we need to study them in order to know them. Charmaine says, ma'am, why is it corresponding? Okay, it's not just corresponding, Charmaine, it's corresponding side. So what I'm actually saying is that each side corresponds to another side. So what I'm saying is side AB corresponds to PQ, BC corresponds to QR, and AC corresponds to PR. Oh. Happy belated birthday, Inganati. Why did you not tell me? Oh, Jasmine's here. Hello, Jasmine and cat and dog.
Oh, they sleeping. It's just me today.
Oh, okay. Okay. Hi, Jasmine.
Can you scroll a bit down for like the whole table of the quadrilaterals?
Yes, it's gonna be okay.
you.
So I'm gonna be honest with you. What I did, Jasmine, is I went to Google and I typed in properties of quadrilateral tables and this thing. So I'm assuming wherever you are, you just jump onto Google and you go properties of quadrilateral. Then you'll be able to find this exact table, because I just went to Google, typed it in, and then popped it up. Okay, so even if you don't get the whole thing, if you Google it, it will come up the whole table. All right. Okay, so we're gonna start at the very top. And remember, guys, these are not things that I can possibly teach you. I can't teach you these. We need to know these. These are things that we need to know about quadrilaterals. Quadrilaterals, again, means 4-sided shapes. So triangles, no. Quadrilaterals, only 4-sided shapes. Okay. And Gibbs says, ma'am, do we need to know all of them? Yes, you do. I know it's a lot, but the reason why we need to know them is because there are certain properties of quadrilaterals that we're going to be using in order to look at these. Okay. Teacher Nels, I love that, the thing that you just put in there. I think that's the link to the table. Thank you, Teacher Nelly. See how easy it was? Okay. I know, Chabitile, it's a lot, but this is why we're going to be doing this. Okay. We know the properties of these. It's going to make it so much easier for us to prove that they are quadrilaterals. Let's have a look at the square. Let's start with the square. What do you know about the sides of a square, guys? What do you know about the sides of a square? So this is X. Oh, Grandma Queen. Good, that they're all equal. Good. So we know that if this side is x, every single side is going to be x. So you can tell this says that the four equal sides. So all the sides of that are equal. Opposing sides are parallel. We also know that this side is parallel to this side, and this side is parallel to that. Now, the reason why something like this is going to be important is because if I do this, if I draw a diagonal from here to there, and then I know that my angles over here, all the angles on the corners are 90 degrees. What do I notice, guys? What do I notice about this triangle and that one? What do we notice about those two triangles? Anybody? Except Flo, who's drinking poison at the moment and possibly dying. Good, they're the same, or be more specific, Tiana. Be more specific because we've been going through those kinds of things just now. Good, they both have right angles, you're correct, Nganati, but what kind of triangles are they? They both have 90 degrees in relation to each other. What can we call them? What kind of triangle? They're right angled triangles, but there's two of them. What can we tell? We've literally just been doing it. We were doing it last week. What kind of triangles are they? I'll give you a hint. One of them says, oh, yes, Tiana, that's Pati, what's up?
Ma'am, we have wait, what was the question?
What
Sorry.
kind of triangles are they?
We have right angle triangles.
Good, they're right angles.
Or
but
like
they're
what?
also-
They are congruent.
Yes, absolutely. They are congruent. That's what I'm looking for. Okay, that's what I was hoping for. Okay, gives us like a good triangle. Yes, I mean, I wouldn't suspect that they're bad triangles, but yes, they are a good triangle. Okay, good. So this is the reason why we went through all those lengths to look at congruency and similarity, because those kinds of things are going to come up. All right, so what we noticed about a square is that if I draw a diagonal over here, these are my sides are 90 degrees. I can also use Pythagoras here. I also know that if I draw two diagonals from one corner to the other, this is going to be 90 degrees on the side. Okay, so on each side is going to be 90 degrees. All of these are important because we're going to be using them to prove that a square is a square. Listen to the words that just came out of my mouth. We are going to be proving that a square is a square. And we're going to be proving that a rectangle is a rectangle. And we're going to be proving that a parallelogram is a parallelogram. But we can't do that unless we know the properties of each of them. Yes, the properties of them. Okay. All right. So the way we can do that is by like we can just say, okay, I know how to prove a square is a square. I'm going to construct a diagonal line. And then I'm going to prove that this triangle, this triangle is equal to that one. So we can do that. Same with a rectangle, guys. What do I know about each of the sides of my triangle? You can even read it off the screen. Already written on the screen for you. Albeit it's written very, very small. But what do we know about a rectangle by looking at it? What do we know about the angles? Good. Opposite sides are equal. Good. So this side is equal to this side, and this side is equal to this. Okay. What else do we know? Only two sides are equal. Yes. This side and the short sides are equal, and the long sides are equal. Okay. Anything else? What else do we know about the sides? That's it. Good. Remember, the opposite sides are parallel. So this side is parallel to that side, and this side is parallel to that side. Okay, what do I know about the angles? Good. All angles are 90 degrees. They are equal and they are 90 degrees. Excellent. 90 degrees, 90 degrees, 90 degrees, 90 degrees. And nothing, okay, we can't say anything about the diagonal. We can just say, if we draw a diagonal, what do I know about this top triangle and this bottom triangle over here? What are they? Kiana, you've already said it once. That's it, Inganati. Excellent. They are congruent. Okay, so those are the kinds of things we're going to be looking at in order to prove all these. Okay. So we also know, guys, just want to highlight one more thing. If I take my rectangle and I do this, what I actually have is this triangle over here being equal to this triangle, and I have this triangle over here. What that actually means is that these things will be equal to you. The diagonals will be equal to you. And that's also something that we need to know. Because it's going to come up when they say to you that this shape, this quadrilateral, is a rectangle. You're going to have to use it. Okay, all right. Let's look at a parallelogram. What do we know about a parallelogram, guys? Yes, it's like yes, it's like sides, vertically opposite sides instead of angles. Good. Yes, Tiana, like the name suggests, each side, like the corresponding side or the opposite sides are going to be parallel. Good, Samuel. The two sides are going to be equal. Excellent. They're going to be equal. What do we know about the angles? Are they 90 degrees? Good. Okay. Now, Latita says two equal sides, but you need to be very careful, Latita. You need to say that the opposite angles are equal. So this side over here and this side over here, those two are equal. And then this angle over here and this angle over here, those are equal. Okay. And also again, if I draw a diagonal like that, this triangle and this one will be congruent. Similarly, if I draw a diagonal from here to there, this triangle and that one will be congruent. But Chimamwe, they're not 90 degrees. They are not 90 degrees. Okay. Thank you. Teacher Nels and Teacher Nels, I cannot emphasize that enough. The wording is so important. Okay, so we need to be able to say the correct thing. Okay, so you need to say opposite angles. You can't just say two angles. Which two angles? Okay, so we need to be very careful with yeah, no, I don't like shapes. Yo, ma'am. Okay, all right. Let's look at a rhombus. Let's look at a rhombus. What do we notice about a rhombus? Tell me. Good. Leopold's just like jumping straight into it. All four sides are equal, 100%. This side is equal, this side is equal, this one is equal. Four equal sides. Yes. What do we know? If says, ma'am, are all the triangles beside the kite going to be congruent? No, because the kite can also be congruent, just in a different way. Okay. Opposing sides are equal. Good. Opposite sides are equal, Samuel. This one and this one are equal. Good. And then this angle and that angle are equal. What else do we know? The sides are parallel. Beautiful, David. Parallel, 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 parallel. Good. And then what do we know about the diagonals? As soon as we see a diagonal, what do we know? Ah, beautiful. Good. If I do this, the angle in the middle here becomes 90 degrees. What do I know about the diagonal? It creates, what does it create? The diagonal creates two congruent angles. Okay. All right. Now, when we look at the kite, we know that the kite isn't 100% going to be the same. I do want to reiterate, guys. Yes, Akwando, that is correct. Interior angles are equal to 3. In fact, all of them interior angles equal to 360 degrees. Right. I want to emphasize, guys, that when we're looking at our kite over here, when we're looking at our kite, we're not just actually looking at a kite, we're looking at a regular. And what I mean by regular is that everything on each side of our kite is going to be the same. Because if we just say kite, I can draw a kite. This is a kite. Does that necessarily mean that all the sides are equal? No, they are not. So we need to make sure that we're distinguishing between a kite and a regular. Now, for posterity's sake, for this, the fact that not everyone is pedantic and OCD like Teacher Coco, they're not going to tell you that it's a regular kite. They're most likely just going to say a kite. But in that instance, you cannot assume that every shape that you see that looks like a kite is a regular. Okay, because what's going to happen is you're going to get to grade 11 and then somebody's going to do this. And then they're going to be like, there's a shape in here. And you're going to be like, oh, I know that shape. It's a kite. But is it a regular kite? We don't know. So the one thing we need to know is in grade 10, they are always going to give you a regular. But every kite that you come across will not be a regular kite. Can I get a thumbs up? Does everybody understand what I mean? Christina says yes. Good stuff. Samuel as well. Good. I need you guys to get that, because once you see other shapes that almost look like a kite, you cannot attribute the same properties of a regular kite to that. Akwando says like, Africa will say the shape is irregular. They do that sometimes. So you need to know whether it's a regular kite or not. Okay. The others, there's a way to think around them in terms of what they actually are, but you'll see now when we go through a trapezium, that trapeziums come in all shapes and sizes. It's always going to be difficult for us to come. Yes, Tian.
Ma'am, so is
Yes.
ma'am saying what the kite story, if it's an irregular kite, the properties are still the same, or is ma'am saying it's changing?
No. If it's a regular kite, then properties apply. But if it's an irregular kite, these properties will no longer.
So if we're gonna get irregular kites the whole time, what's the properties
No.
of those irregular kites?
No. You will not get irregular kites. In grade 10, you're going to get regular. So you can
Oh.
use them. Okay.
Thank you, ma'am.
It's just that at some point in your high school career, they're going to give you shapes that look like kites. So or they're not, they will be a kite, it's just that they won't be regular. Okay. Zanogute and Chimwemwe, what I'm saying is, what we are looking at over here is a regular. Now, this thing, if I draw this thing, if I do this is technically also considered a kite. It's a quadrilateral with 3 sides. But just because it looks like a kite, it doesn't mean that it is. Okay. So we cannot then say that it has the properties of it. Hope that makes sense. Okay. Now, if we look at the properties of a kite, what we're going to notice is that the 2 short sides of a regular kite are equal. These 2 sides are equal, and these 2 sides are equal. That's the other like teacher Marlies was like, nah, I don't like kites. I see why. It's true. Okay. It's very true. All right. These 2 sides are going to be equal. If I draw a diagonal, so if I draw a diagonal from here to there and from here to there, what happens is here in the middle, I get a right angled triangle. And I can't remember if it was you, Samuel, who was like, everything is going to have congruent triangles except for a kite. No, a regular kite also has congruent triangles. It's just that this one and this one will be congruent, and this one and this one will be congruent. So there'll be 2 pairs of congruent triangles inside our kite. Okay. So it will always be there. It will always be there. All right. Okay. Now let's have a look at the trapezium. We're not even going to spend that time on the trapezium. I'm telling you guys now. I'm telling you guys now. Even maths teachers, we hate trapeziums. We hate them. We try to stay away from them because they suck. Because they suck. All right. Now have a look at what's happened here. We have a trapezium. Tell me, when you look at a trapezium, what properties of a trapezium are we seeing here? What properties do we have? Are any of the angles equal? No. None of the angles are equal. Okay. The only thing we can say about a trapezium is that this side and this side need to be parallel. They won't even be equal in length. They will just be parallel. Okay. And then nothing else. Nothing else about a trapezium. The only thing that we can say, though, Yes, that's what I want to get into. The only thing that we can say, because it's a quadrilateral, is that the four sides on the inside of my quadrilateral will be equal to 360 degrees. That's it, but none of the angles are. Right. The only difference will be in an isosceles.
But we can also say,
yes, ma'am.
can we say that adjacent angles are add up to 180 degrees in a trapezium?
Yes, we could. Yes, we could. But it's also in contention, because if your trapezium is irregular enough, they may not. Okay. I've seen examples where it doesn't quite do that. Okay. But I haven't seen that property that often.
Mhm.
I'll have to double check that. Okay. I'll have to double check that. Samuel, yes, all interior angles of a quadrilateral are 360. Yes, Patrick.
Okay.
Ma'am, aren't those two angles going to be 90 degrees? Because like
Which
we have
one?
like
These
parallel
ones?
lines, and then like the distance
Ones.
between them is like, yeah, like 90 and
What
90.
What if this one is 91 and that one is 89?
Then it's not parallel lines. Then the lines
Yeah.
can be parallel.
Well, they can, because remember, this is just
Isn't
a
the distance
convex.
between them supposed to be constant though, ma'am?
Yes, it is. The distance between this one and this one. But you see how the distance is constant? I can still draw a line like that. The distance is still constant. Doesn't mean that there's a 90-degree line, though.
Wait. Hi,
I'm sorry, my sweetie. It doesn't automatically mean that. It doesn't automatically mean that it's 90 degrees on each side. Okay. The only time we can assume that is if they
Okay,
draw
ma'am.
if they draw a square. Only time we can say that. Okay. All right. No worries, my sweetie. All right. The isosceles trapezium is the only one that's going to come with its own kind of. What you can say about an isosceles trapezium is that this side and this side will be equal. And then these two sides are parallel. That's a, oh, no, I lied. Okay. And then they bisect each other. The diagonals like this side and this side are equal, and this side and this side are equal. Oh, no, the other way around. I'm lying. These two sides are equal to each other on the top. Okay. I know, Tiana, she's also like, yay. What can, and so yes, Tiana.
Ma'am, can I please like get a definition for isosceles quickly? Like, does it mean equal or something? Because the isosceles trapezium looks straight, but the other one looks skewed. That's it doesn't mean equal.
Yes, okay, so isosceles just means that my base angle, so this one and this one will be equal, and this side and this side will be equal. That's what isosceles means. Means that my base angles and my base side are equal.
Thank you, ma'am.
Okay. All right. The same with an isosceles triangle, as we know, the two base angles and the two base sides. All right. Okay. How to relax? It's not that deep. All right. We're going to look at this quickly. All right. Now, this says QRF is a parallelogram, and they even give you some of the things that you need to know. It says SY is equal to QX. Prove that PXRY is a parallel. Okay. Now, look at the drawing we've been doing. Look at the drawing we've been doing. They're telling us that PQRS. So I'm going to map out PQRS. PQRS, those quadrilateral. They're saying that that is a parallelogram. Immediately when we hear that, what are we going to go and do, guys? What are we going to go and do? I'll give you a hint. There it is. What do we know? What do we know, guys? What do we know? Anybody? What do we know? Good. Two pairs of equal sides. Excellent. Pachu, what else? Okay, two pairs of equal sides. But
Ma'am,
now you can't just say two pairs of equal sides. Tell me, be specific.
parallel lines
Good, yes. I don't like
and
the fact that
opposite
you're
angles are
saying-
equal.
Good. I don't like the fact that you're saying just parallel lines, like that's supposed to mean something. You must say PQ and RS are parallel, ma'am.
Oh.
Yes, you say that. Okay. And
Okay,
then we also know that
so
it's okay, Miss Judy. And we know that the opposite angles are equal. So angle Q is equal to angle S. And
Yes, ma'am.
P is equal to angle R. Okay, good. Okay. Anything else? I see Akahang say QR is equal to PS, agreed. And I also know that PQ is going to be equal to RS or SR. That's the one. Okay. Now it says here, all sides equal to 90 degrees. I'm not sure about that. I'm not sure about that. Okay, and then it says QX is equal to PY. Okay, I agree with that because of the way that it's been cut out. But what I want us to note here, guys, is that they're saying to us that we want to prove that PX, I'm going to map that out, PX or Y is a parallelogram. Take one that we've been looking at. PX and RY, those two are equal to each other. But we know a couple of things about diagonals. We know a couple of things about the sides of each of these, right? What can we say about this? Okay, good. Okay. Remember, it says QX is equal to PY. Okay, I don't think that's going to help us in this case. Okay, but it could. QX is equal to PY. Which other side is also going to be equal to QX, guys? WR. With the W. YX. XR. No, I'm not sure about that number. Okay. Somebody said QX is equal to SY. Agreed. Okay, so this one is also equal to SY. Which other one is it equal to, guys? Have a look. And remember, everything that we're mentioning here, it's just properties of a parallelogram. Good, is equal to Rx. Good, there we go. It's equal to Rx. Let's have a look at QR. What other side is QR going to be equal to? QR is equal to which side, guys? Good. QR is equal to PS. And all of these guys, we can literally write the property. We can say here that opposite sides of a palm, when we write parallelogram, we write PARM, are equal. Okay. Okay. And then over here for QX and PY and SY and RX, we can say that diagonals are. We've been told that these diagonals of a palm are. Okay. Now I want to write. I'm writing something completely different for my brain. All right. One last thing. It says here PY something to XR. What do we know needs to be absolutely there in a parallelogram? What do we need to know? Even if the sides are equal, if the sides are equal, it could easily be a rectangle. But what do we know about PY and XR? What do we know about them? That's it. Local. Excellent. Okay. In order for it to be a parallelogram, it needs to be, the sides need to be parallel to each other. And that's also because opposite sides of a palm are parallel. I'm going to just write the parallel symbol because we're going to run out of time. Parallel. So I can therefore say, therefore, PXRY is a parallel. So these are the kinds of things that we're going to be doing. We're going to be using the properties of quadrilaterals to prove that they are, in fact, the quadrilaterals that exist. I'm going to give you guys homework today while teacher Nels puts up the poll. Okay. Please poll teacher Nels. Okay. Homework. Here is your homework. Go and learn the properties. Learn the properties of quadrilateral. That's your homework. You've got until Wednesday. You've got until Wednesday to learn the properties